Today, we're going to look at Chapter 20, which is more about our tests. As we work through Chapter 20, you'll continue to have some problems out of the Chapter 19, where you go through the whole hypothesis test, and you can use the ideas that we're talking about to make your conclusions here as well. Some of the homework in 20 will be on Pearson because it's heavily tested in the multiple choice questions, but we will also need to be able to write it out by hand. My plan is to quiz Chapter 20 and 19 together. So we'll have a Chapter 19 and 20 quiz on Friday, okay, where you'll have to go through an entire hypothesis test this Friday. Okay, you have to walk through, do an entire hypothesis test, and then you'll have to talk about what we talked about today, the different types of error that could be made based on that test. Okay, so here's the thing about statistics. We can make a conclusion, but we could also be wrong. We could turn around and in another sample get a totally different conclusion, and we were wrong. So what are those types of error? Well, the first thing we want to talk about is the alpha level. Okay, the alpha level is also known as the significance level. This is usually that 5% mark. If the p-value is less than 5%, 0.05, then we reject. And if it's above 0.05, even by a little bit, we fail to reject. This gives us a hard line, so we don't have to make a judgment call. On a lot of AP questions, it will give you a significance level it wants you to use. Sometimes it'll use 0.1. Sometimes it'll use 0.01. But that's the line that you're going to draw based on that problem. And if it's below that, right, remember a small p-value, less than our standard, means it's unlikely to be sampling variation, and so we're going to reject. Okay. So it's a threshold we use to determine if it's statistically significant. If it's less than our alpha, we reject the null hypothesis. Okay. If it doesn't tell you, we generally choose 0.05. This should be chosen before we even do the whole test. We write our hypotheses, we set our alpha level. We don't want to get a conclusion and then make our determination, right? We determine ahead of time where we think we're going to draw that line so that we're not like cheating. Oh, well, my p-value was 0.6, so I guess I'll use an alpha of 0.1 because I want to reject, right? Or I'll choose an alpha of 0.05 or 0.01 because I don't want to have to make a confidence interval, so I'll fail to reject. Okay, so we don't set it at the beginning, or we set it at the beginning of the problem. So the thing about, wouldn't change. The thing about hypothesis tests is they're just hypotheses. There's no real answer. We don't really know what the population proportion is. And so we could be wrong. And there's two types of error that we can be wrong. They're really creative names. They're called type 1 and type 2 error. Okay. Type 1 error happens only when we reject. If we reject, it's possible that we made a type 1 error. We were wrong. The null hypothesis is actually true, but we rejected it. Type 2 error can happen only when we fail to reject. So if we failed to reject, it's possible that we were wrong. The null hypothesis is not true, and we should have rejected. And the power of a test is the ability to be correct when we reject. Okay, power is correctly rejecting a false hypothesis. Okay, so you might want to add that. Now we actually know the probability of a type 1 error. We set that at the beginning of the problem. The probability of a type 1 error is your alpha level. you set your alpha at 0.05, you're going to reject approximately 5% of the time. So there's 5% chance that you're wrong. So our type 1 error, the probability of that is your alpha level. So if I increase my alpha level, I increase the probability of making a type 1 error. I also increase my power. Okay? So my alpha and my type 1 error and my power are directly related. This goes back to like a concept we sometimes skip over when we discuss it in Algebra 2. Directly related means if I increase one of these things, the other ones increase as well. If I increase alpha, I increase type 1 error, I increase power. If I decrease alpha, I decrease type 1 error, I decrease power. Okay, so they all increase. That means they all increase or decrease together. Type 2 error is indirectly related.
That's only for the type 1. Is it all increase and decrease?
The type 1, the alpha, and the power. Okay. If I increase one of those, the other ones increase. Okay? If I decrease one of them, the other ones are decreasing. Type 2 error does the opposite. If I increase these, it does the opposite. It decreases. If I decrease those three, the type 2 error increases. Okay? So it does the opposite. Of alpha, type 1, and power. Okay? Now, which one's worse? Is a type 1 error worse? Is a type 2 error worse? It depends on the situation. Okay? It depends on the situation. It depends on who you are in the situation. Sometimes a type 1 error is worse for the company, but better for the consumer. Sometimes a type 2 error is better for the company and worse for the consumer. It depends on the situation, so you have to think about it. Here's our first example. A pregnancy test. The null hypothesis is that you are not pregnant. There has to be enough evidence, hormones, for the test to say you're positive, you're pregnant. Okay? So there has to be enough evidence. There has to be enough hormones in your body for it to say you're pregnant. If I fail to reject, that means there's not enough evidence to say that I'm pregnant. Right? There's not enough hormones. The evidence is the hormones in that type of test. If you think about a COVID test, you're taking that swab, right? It's looking for the virus, the viral load. If there's not enough of the viral load, it's not going to detect it. There's not enough evidence to say, yes, you are positive. Okay? We reject the hypothesis, the null hypothesis. There is enough evidence to say there's enough hormones, there's enough virus in that sample to say, yes, you are pregnant, yes, you have COVID. And now what are the types of error? So if it's a type 1 error, we have rejected the null hypothesis. Meaning we say that I'm pregnant. And I cry myself to sleep because I don't want to start over. But they're wrong. It's wrong. That's a false positive, right? Told me it's positive, but it's incorrect. Okay? That could be devastating to someone who was actually trying to be pregnant, right? That could be a relief to someone who doesn't want to be pregnant, right? It depends on the situation. The type 2 error is the opposite. We fail to reject. It says you're negative, but it's wrong. You actually are pregnant. That's a false negative, right? That's bad for the baby, right? Because you go about your life eating sushi and lunch meat and dyeing your hair. You have no idea how many things you are not allowed to do when you're pregnant. I don't know. Seeps in your skull. I didn't dye my hair for a year because I was pregnant. And then after you have the baby, you don't got no time. You have no time to go get your hair done. So yeah, they tell you not to dye your hair. They say not to eat sushi. They say don't eat lunch meat.
Why no sushi?
Because of the raw fish.
Doesn't it depend on like mother to mother? Or maybe
No, they make blanket statements like that. You know, obviously don't drink, don't smoke. Right? Those are the big ones. But like if you think you're not pregnant and you go about your business, right? You're hurting the baby with the false negative. Okay? And then all of a sudden, oops. you think you're getting fat from the alcohol and the cookies. But okay. So, same idea with your COVID tests, right? A false positive says you have to quarantine, right? When it started for 10 days, that was literally the longest 10 days ever. How many of you got quarantined for 10 days? I got quarantined for 10 days at the very beginning of the school year last year. First 10 days of school, I was not here.
I had it during the winter break, so.
Yeah, it was awful. It was awful for me. It was awful for you. Anyways, right? That was the longest 10 days. Well, that's par for the course in a math class, right? But if that was wrong, I stayed home for nothing, right? And my students missed out on actually learning for 10 days for no reason, okay? So that false positive was bad for my students and it would have been bad for me, right? But what about a false negative?
I think it's bad either way.
Right, it's bad either way. The false negative means you think it's just a cold, you go live your life, and other people probably get sick from you. We're learning more and more. It's less and less severe than we originally thought it was, right? It's becoming more and more of like a cold, a minor inconvenience for most of us. But that's the idea of error, okay? Depending on the conclusion, that's the type of error you could have made based on your test. Now, a lot of problems that deal with type 1 and type 2 error ask you to explain both types of error, okay? So it's one of those things. We have to memorize stuff. We have to memorize what type 1 error is. Type 1 is reject, right? One word in reject. Type 2, fail to reject. Fail to reject. 2 words. Fail, reject. Right? Two words. Okay? So let's look at another example. The justice system. Okay? What is the null hypothesis in the justice system? But you are presumed innocent, right? Innocent until proven guilty. So the null hypothesis is innocence. And the alternative, is there enough evidence to convince me you are guilty? Right? There has to be enough evidence for the jury to say, yes, you did it. Not enough evidence, right? Beyond the shadow of a doubt, right? Beyond a reasonable doubt. That's the standard. That's the alpha level. That's pretty vague. Reasonable doubt, right? So if we reject, what are we saying? No, if we reject the null hypothesis, we're saying
Have you done the evidence to prove that he's not innocent?
guilty, right? What does the judge say? Bam, guilty, right? That person's going to jail. What if we fail to reject? Does the judge say innocent? He says not guilty, right? The judge says not guilty because we don't have proof of your innocence. We just don't have enough evidence to convict you. So we say not guilty. Okay. That's a great parallel because we don't say, I accept the null hypothesis. We say, not enough evidence to say it's not for now. Not enough evidence to say that you're not guilty, right? So what is a type 1 error? Right, we say they're guilty, right? But they're actually innocent, right? So that's an innocent person. Goes to jail.
That's type 2. He did it.
An innocent person goes to jail. That's your type 1 error, right? You've rejected the null hypothesis of innocence, and that person goes to jail, but you're wrong. And so your type 2 error. Right. A guilty person is free to go. We can think of a few examples in history. The glove don't fit.
Jeffrey Dahmer.
No, he was guilty, and he went to jail.
A guilty
That was power.
free to go.
O.J. Simpson.
But no, Jeffrey Dahmer didn't go free.
He went to jail for a while and then came back, right?
He was killed in jail.
He had a trial and then he let him go. And then he went back to school. Or he went back to work.
Possibly. Remember, he was set on bail. But that was power. What was the power? The heads in his fridge. That's the evidence. There was a lot of power there, right? To correctly convict a guilty person. That's power. Okay? So let's think about it this. Sometimes when we take it out of the context of statistics and we put it in something more real, it makes more sense, right? So power is correctly convicting a guilty person. Okay. The more evidence against that person, the more likely they are to convict them. Right? When they find the bodies and body parts in your fridge, you're not likely to get off. Hopefully.
Hopefully.
What it does is the more evidence is it increases the, like, it gets your hypothesis closer to reality, and so you're more likely to reject. Okay? So there's a good example. This is a great article to read that kind of explains it more. And I will send out that link for you, or you can look it up. There's actually a little applet where you can see the normal models and how they overlap and how you increase alpha, it increases power, but it doesn't work on my phone or it doesn't work on Apple devices. Okay, so here is an example from the 2003 AP exam. When a law firm represents a group of people in a class action lawsuit and wins that lawsuit, the firm receives a percentage of the group's monetary settlement. The settlement amount is based on the total number of people in the group. The larger the group and the larger the settlement, the more money the firm will receive. A law firm is trying to decide whether to represent car owners in a class action lawsuit against the manufacturer of a certain make and model for a particular defect. If 5% or less of the cars of this make and model have the defect, the firm will not recover its expenses. Therefore, the firm will handle the lawsuit only if it is convinced that more than 5% of this make and model have the defect. The firm plans to take a random sample of 1,000 people who bought this car and ask them if they experienced this defect in their cars. Define the parameter of interest and state the null and alternative hypothesis this firm should test. So take a second, write down what the parameters, what we are trying to estimate, right? P is the proportion of what, and what are your hypotheses? Okay, our parameter is the proportion of cars with the defect. They can't go out and test every single car of this make and model, right? They have to do a sample. So they're going to sample 1,000 people and see what percentage of their cars have the defect. So what is our null hypothesis? That P equals but what percent of the cars? 5%. So our P is 0.05. It helps in this chapter when it's asking about type 1 and type 2 error to write your hypothesis in a sentence. 5% of the cars have the defect. The company needs convincing evidence that it's more than 5% so they can recover their expenses. So what's our alternative?
95% of the cars don't have the defect.
No, it is always the same numbers. Greater than. Okay. If it's less 5% or less, they do not recover their expenses, right? So they're going to do an experiment and they need evidence that it's going to be more than 5% so they can make some money. Okay, don't let lawyers fool you. They're in it to make some money. Sure, they're going to help you. But they're only going to help you if they know that more than 5% of the cars have the defect.
Would it be more than or less than?
It's greater than. They only if it's convinced that more than 5% of the cars have the defect. Okay? This is telling you that they will not recover their expenses.
If it's 5%, they don't recover.
Right.
If it's greater than 5%, they do.
Correct. Right? So then that is more than 5% of the cars have the defect. Okay. Now, here's an important part. In this context, describe type 1 and type 2 errors and describe the consequence. What happens if the firm makes that error? Okay. So you're only getting half. If you describe the type 1 and type 2 error, you're getting half the credit here. You have to also see the underlining. That means really pay attention and make sure you do both things, right? So type 1 error. Okay, type 1 error. Is it reject or fail to reject? Reject, right? Type 1, one word, reject. I reject the null hypothesis, but it's true, right? That is not in context. That's not enough. Okay? I like to write that so then I know how to interpret it in context, what I'm going to say. Okay? I'm going to say that the firm incorrectly, can't spell, it's just rejects the null hypothesis and believes the true proportion of cars with the defect is above 5%. But they are wrong. What happens? They don't recover their expenses, right? And they don't. There's your consequence. Recover the expenses. And most of these lawsuits, the lawyers don't make you pay for anything, right? They pay for the research. You only get paid if they get paid, right? They only charge you if they win, right? So they got to make sure they're confident that they're going to win, so that they recover all the money they spent to do that sample, right? All the hours they have billed for their lawyers, okay? So there's our context and there's our consequence, right? They don't recover the expenses, okay? Can you write your type 2 error out? That's failed to reject. Bless you. The firm incorrectly fails to reject the null hypothesis and believes the proportion of cars with the defect is less than 5%, but they're wrong. What do? Right. They don't take the case. And miss out on making money. Yes?
Why do we say it's less than 5% if our hypothesis is equal? Why can we say that?
Just because the problem says 5% or less, right? So in the problem, they believe it's either 5% or less. There just wasn't enough evidence, and so they're not going to reject. Now, if you said they believe it is 5%, you would still get that correct. Okay?
So what if we said the defect is 5% or less?
That's fine. Yeah, if you say they believe the defect is 5% or less, they're still not taking the case, right? And they lose out on possible money that they could have made. Okay? Now, the problem doesn't ask for this, but I have seen problems that do. What is the power again? That idea of power is difficult, okay? So power in this case is their ability to correctly detect that over 5% of the cars have the defect. Okay. It's rejecting and being correct. That's power. And it's not always known. Okay. We said that type 1 error is alpha, your significance level. Well, type 2 error is beta. So fancy B. This is alpha. We get to learn our Greek alphabet quite a bit in statistics. More so in pre-calculus and calculus. They use a lot of Greek alphabet. Okay. If alpha and beta are type 1 and type 2 error, the power is 1 minus beta. You don't always know beta, so you can't always calculate that. Very rarely, actually. But if it tells you that the probability of type 1 error is 25% and it asks for the power, you should know you can just subtract that from 1. Okay. The National Center for Education Statistics monitors many aspects of elementary and secondary education. Its 1996 numbers are often used as a baseline to assess changes. In 1996, 34% of students had not been absent from school even once during the previous month. In the 2000 survey, responses from 8,302 randomly chosen students showed that this figure has slipped to 33%. Do these figures give evidence of a change in student attendance? So there's our keyword for the alternative hypothesis. Okay? We're not worried about decrease or increase, it just wants to know if it changed. Okay? So my null hypothesis is P equals 0.34. We're comparing to the 1996 numbers. Okay? My alternative, P does not equal 0.34. Okay? My P hat is 0.33 and N is 8302. Okay? Now, we didn't set alpha levels yet, but you can, starting today, you can set your alpha, 0.05. And that's going to be that threshold. If it's less than that, you're going to reject. If it's greater, we fail to reject. There's no guessing anymore. Okay? So start putting that into your problem. Check your conditions. Did we need help on that? Is 8,302 less than 10% of all U.S. students? Absolutely. Is the sample random? Sample is random. You can say stated, right? Randomly chosen students. Don't say representative when the problem tells you it's random. It's random. Okay, look for those keywords. And NP and NQ, 8302 times 0.34 and 8302 times 0.66. Remember that we are doing this whole problem under the assumption that the null hypothesis is the true proportion. So 8302 times 0.34 and 5479.32. Okay, so since conditions are met, a normal model is appropriate. I will use a one prop Z test. Remember on Friday when we looked at the scoring guide, right? Identify the test by name or formula. There's the name, and check conditions. There are conditions, right? Each free response question is worth 4 points. The hypotheses are usually 1. The conditions are usually 2. The calculations are 3, and the conclusion is 4. Okay? By the time we are done and ready to take this test, these should be the easy ones because we've done them so many times and they're fresh. Okay? So calculate our z-score. Our p hat, 0.33, minus our p naught. Okay? Remember that the hypothesis is always what we subtract. So it's our sample minus the hypothesis, and we're using 0.34, 0.66 over 8302. Remember that you are using your hypothesized proportion. That's what we believe is true until proven otherwise. So let me get that real quick. The square root of 0.34 times 0.66 divided by 8302 is 0.0052 over negative 0.01. And then I got negative 1.923. And then we do normal CDF. Now, our hypothesis was not equal to, right? So our z-score determines which way we do the normal CDF. The z-score is negative, we use negative 99. Okay. When it's greater than, we will always use positive 99. When it's less than, we always use negative 99. When it's not equal to, the z-score tells us which way to do it. If it's negative, we do negative 99. If it's positive, we do positive 99. Okay? Negative 99, answer 0.0272. And I'm going to times that by 2 because I want both tails. I want to know greater than or less than in either direction, or that extreme 0.544. Now, when you were doing this without an alpha level, you very well could have said, since my p-value is above 0.05, I fail to reject. But you could also say, since my p-value of 0.0544 is so small, I reject. There are times when both answers are acceptable, depending on what you base your conclusion on.
So let's fail to reject so we don't have to
Well, we set an alpha level, though. That's what we love about the alpha level, right? When we set an alpha level as the teacher, as the test, then there is no back and forth. It's greater than. It may only be slightly greater than 0.05, but it's greater than. So we're going to say, since my p-value, and this is where this is going to change just a little bit with an alpha level, of 0.0544, I'm writing out a cookie cutter statement here, is greater than my alpha level of 0.05. I reject. Nope. I fail to reject. It's greater than the null hypothesis. So we fill in things like p-value. This is greater or less. This is your alpha, and then it's fail or reject. So we can say, we set an alpha of 0.05 at the beginning. It's greater than. It may only be slightly greater than, but we failed to reject because it's greater than that. It needs to be small, smaller than alpha to reject. Angelica. The alpha level. Normally you will set it to 0.05 unless the problem says use a significance level of 0.01 or 0.001 sometimes. It'll tell you in the problem. If not, you can set it to whatever number you want. I mean, I had a kid be a smart aleck one year, and he was like, my alpha is going to be 0.0235789764, and he gave me like 12 digits. Because technically, that could be your alpha level. You just have to set it at the beginning of the problem. Okay?
If I set my alpha level 9.
0.9 is too high. It can't be above 0.1. Yes. Almost. Right? This is my conclusion. The next sentence is, there is not enough evidence to convince me. And here's where you can say the proportion is not 0.34, or, like the back of the book does, you can repeat the question, of a change in student attendance. Okay, so that's kind of up to you. Of a change in student attendance. That's kind of repeating the question. Or the proportion of students not absent even once is not 0.34. It's kind of easier to just repeat the question, right? But we say, since my p-value, you include the actual value in your sentence, is greater than or less than my alpha. If it's greater than, we fail to reject the null hypothesis, and there's not enough evidence. Failing to reject means not enough evidence. Rejecting means there was enough evidence to say that's not the null hypothesis, that you have COVID, that you are pregnant, that you are guilty. There is enough evidence